Hey mathematicians, so today we are finishing up our unit on inequalities with systems of linear inequalities. So just remember that a system of equations was two or more equations with the same variable. So it's got to have the same variable so you can graph it on the same x and y plane. Or if it's a real world problem, the same distance time plane, whatever. So remember we had infinite solutions if the lines overlapped, one solution if the lines intersected, and no solutions if the lines were parallel. So we can have the same kind of thing. A system of inequalities is two or more inequalities with the same variables. So the solutions are a little different. The solution is not where the lines cross, but where the shaded areas overlap. So you could have parallel inequalities that face away from each other, so you would have no solutions, but more commonly, you have two shaded regions that overlap somewhere, and any coordinate inside that shaded region is part of the solution set. So let's take a look. We're going to graph these two inequalities on the same x and y plane. So in this case, negative 2/3 is our slope. 3 is our y-intercept. So we're going to graph our boundary line by plotting the y-intercept first, then going down 2 and 3 to the right. So down 2, 3 to the right. Then we look at our inequality signs, we make our decisions. Is this boundary line solid or dotted? Is there a line under the inequality sign? If the answer is no, it's a dotted line. So we got this dotted boundary line, which is not included in the solution set. Do we shade above it or below it? Well, since it's in slope-intercept, all we have to do is look at the inequality sign. Since it's greater than, we are going to shade above it. Second inequality looks a little strange. Okay, so we get y is less than or equal to 1. So remember, if you don't see x, what did you multiply x by? 0. So the slope of this line is 0, which means it's a horizontal line. The y-intercept is just what you see. So the y-intercept is 1. Then we make our decisions. Is the boundary line solid or dotted? Since there's a line under the inequality sign, it is a solid line. So the y-intercept is 1. It's horizontal, so any other coordinate where y is 1 is fine. Then draw a solid horizontal line. Now do we shade above it or below it? Since it is slope-intercept, we just look at the sign. It's less than, so we're going to shade below. So it looks like there's a really small intersection overlap, but there's not. There's an infinite number of coordinates in here. Remember, this goes on forever. This goes on all the way over here. So we're talking about a solution. Any coordinate in this overlap is part of the solution set. Okay? Not the dotted line, but the solid line still counts. So if I pick right here on that solid line at 6, 1, that's part of the solution set. Right? 5, 0 is part of the solution set. 7, -1. Any of the infinite points that you see in this area, you could write down as a solution. So let's take a look at delta math and how we're going to do this online. So here we go. We've got y is greater than 1/3 x plus 3, and y is less than -x minus 5. So in this case, they're both in slope-intercept, which is nice. Up here, our y-intercept is 3. And the slope is 1/3. So remember, we're going to go up 1 and 3 to the right. Okay, now we make our decisions. Should this line be solid or dotted? There's no line under it, so change it to dotted. Should we shade above it or below it? Well, it's greater than, so we're going to shade above it. So the second line, we've got y is less than negative x minus 5. So the y-intercept here is negative 5. And the slope is negative 1. So remember, that's going to be down 1 and 1 to the right. Is it a solid line or a dotted line? There's no line under the inequality sign, so it does not include the line, so change it to dotted. And it's a less than sign, so we want to shade it below. So this is the overlap. Any coordinate in here counts as a solution. So when we put our point down, any one of these counts. So I'm going to pick negative 9, 2, because it's right there in the middle where I can see. And look how great we are. Remember, when you're doing the delta math, you can always look at an example if you're having trouble.